Now we are going to discuss the uniform motion. Okay, but in this case we are going to discuss uniform motion with the help of velocity time graph. Velocity time graph is what if you take velocity of an object on y-axis and time on x-axis and plot a graph, then such a graph is said to be velocity time graph. Okay, now uniform motion is such a motion in which object covers equal distances or equal displacements in equal intervals of time. Okay, now if object covers equal displacements in equal intervals of time, it means that the velocity of the object is constant. Velocity of the object is constant. Okay, now if you have to plot a graph in which the velocity of the object is constant, so what you will do, you will be taking velocity on y-axis, time on x-axis, and velocity remains constant. What does it mean? Suppose it starts from this point 0 at from 0 or from O it starts. This is A, B, C, D. Okay, and these are the different time instants. Say this is 0 second, this is 1 second. This is 1 second, this is 2 second, this is 3 second and 4 second. Okay, and here the distance initially, now we are talking in terms of velocity only. So say initially velocity was 0, or say initially also velocity was say 20 meter per second. Here also it is 20 meter per second. Here also it is 20 meter per second. Here also it is 20 and last also 20. Now someone may ask that, sir, how is it possible that at 0 second it is 20 meter per second? So actually this is the time where we started to observe the motion. It is not the time where the object has started the motion. No, it is the time where we started to observe the motion. Suppose that you are watching an object moving, it is already in motion and you start to take the motion now. So this is the time, is 0 second at which you started to see the motion of the object. Okay, so this is what we have, and if we plot it here, so these are the axes 0, then 1, 2, 3, 4 like this, and this is 10, 20, 30, 40. Now at all points the distance covered is 20 meter per second. So you can see here at 0 second it is here, at 1 second it is here, at 2 second it is here, at 3 second it is here, at 4 second it is here. If you join all these points you will get a straight line. So uniform motion, for uniform motion, velocity time graph of an object is a straight line. It is a straight line parallel to time axis. Straight line parallel to time axis as shown here. Okay, so this is what the uniform motion. Now suppose we have to discuss velocity time graph for non-uniform motion. Now in two senses there the motion can be non-uniform. In two ways the motion can be non-uniform. Let us discuss that. Here we have we are writing this non-uniform motion, Then in this non-uniform motion, two ways are there. Non-uniform means object covers unequal distances in equal intervals of time. Now you see, these unequal distances can be traveled in two ways. It might be possible that a distance covered by the object or displacement covered by the object. Why I am saying or? Because if object is going on a straight line, distance and displacements are same. So if the object covers unequal distances or unequal displacements in equal intervals of time, then that can be in two manners. If the velocity is increasing with time, then it covers more displacements in equal intervals of time. Or if the velocity is decreasing with time, in that case object covers less displacements in equal intervals of time. Okay, so we have to consider both. So non-uniform motion is what we are talking about, and in non-uniform motion the first case we will see is when the velocity is increasing with time. velocity is increasing with time. If velocity is increasing with time, okay, and this is if the velocity is increasing with time, okay, we can consider it in this manner, that suppose this is non-uniform motion, and in that also which type of non-uniform motion? Say positive acceleration, because here the velocity is increasing with time. If we consider the velocity, if we consider that the velocity is increasing uniformly with time, that is called uniform positive acceleration. Uniform positive acceleration. Uniform positive acceleration means what? That there is equal change in the velocity. What is acceleration? Change in velocity with time. Okay, rate of change of velocity. Now what we are saying, uniform positive acceleration, of course it is a non-uniform motion. Why it is non-uniform motion? Because in that case velocity is increasing with time and distance covered by the object actually increases with time, and that's why it is non-uniform motion. Velocity is increasing with time and it is increasing uniformly, that's why we are saying it uniform positive acceleration. So let us first study this case. Okay, suppose that it starts from this point O and goes like this. Okay, say this is A, B, C, D, like this. Okay, and times are 0 second, 1 second, 2 second, 3 second, 4 second, and so on. And here the velocities are, suppose that initially the velocity was 0 meter per second, then after 1 second the velocity becomes, say, there is uniform change, so say it is 10 meter per second, then here say it is 20 meter per second, then it becomes, say, 30 meter per second, then it becomes 40 meter per second. So here you can see that there is uniform change in the velocity. Here the change in the velocity is 10 minus 0, that is 10 meter per second. Here it is 20 minus 10, that is 10 meter per second. Here it is again 30 minus 20, that is 10 meter per second. Again it is 10 meter per second. So there is uniform change in the velocity in equal interval of time, that is 1 second. Okay, so what you have to do now, you have to plot the graph for this. Okay, so here you have distance, here, sorry, not distance, now you have velocity, and velocity is in meter per second, and here you have time, and time is of course in seconds. Okay, so here we have this. Now you can see here that velocity is going like this. This is 0, 1, 2, 3, and one more we want, which is say this is 0 second, and one more is 4. Okay, and as far as the velocities are concerned, here it is 0, then 10, then 20, then 30, and at last it is 40. Okay, let us plot this tabulated data. So here on y-axis we have velocity, on y-axis we have velocity, which is in meter per second, and on x-axis we have time, and that is in seconds, of course, in seconds. I hope it is visible to you all. Okay, in seconds. Okay, then here we have, this is, let us plot the time. This is 0. Here we have 0. Then we have 1. Then we have 10. Then we have 20. Then it is 30. Then it is 40. It is in meter per second. Then we have this is 1. Then 2. After that here we have 3. Then we have 4. Okay, now at 0 second it is 0, so at 0 second the velocity is 0, so it is somewhere here. Okay, then at 1 second it is 10, so at 1 second it is 10 somewhere here. Then at 2 second it is 20, so it is it will be somewhere here. Then at 3 second it is 30, so it is here. And at 4 second it is 40, so it will be here. Okay, if you join all these points, though we have not taken the scales properly, but still you can see that all these points are falling on a straight line. So this is what the graph for uniform positive acceleration, uniform positive uniform positive acceleration, and when it is there, then object covers more distances, more displacements in equal intervals of time, and its velocity is increasing uniformly. Okay, now in this only, if we discuss, again this is non-uniform motion, if it is uniform negative acceleration. Okay, in this case only I am explaining it. If it is uniform negative acceleration, so try to understand this case, that what is happening now, that the velocity is uniformly decreasing with time. Okay, so what we will do now is, we will be plotting it. I will be arranging it here only. So it is uniform negative acceleration. Okay, just we have to tabulate the data accordingly. So we are having new data now. Okay, we need some new data here. So it is 0, this is 10, that we don't want now, because velocity is now decreasing with time. Okay, so if we start, let us start from say first point, and at first point the velocity is say 40 meter per second. Okay, now it decreases to say 30 meter per second in 1 second, then it decreases to 20, then it decreases to 10, and then it becomes 0. Okay, like this it is. So it starts from 40. So here first time it is 40, then it becomes 30, then it becomes 20, then it becomes 10, and last it becomes 0. Okay, is it clear? Now what is there? Now you have to, if you have to plot the graph, you can see that there is equal change in the velocity. Velocity is changing by 10 meter per second here, and in fact it is minus 10 meter per second, because it is 30 minus 40. Then it is 20 minus 30, again it is minus 10 meter per second, again it is minus 10 meter per second, again it is minus 10 meter per second. So velocity is, after each 1 second, velocity is decreasing by 10 meter per second. If you plot the graph here, you see that initially at 0 second it is 40, at 1 second it becomes 30, so it will be somewhere here, at 2 second it is 20, so it will be somewhere here, at 3 second it will be 10, so it is here, and at 4 second it is 0, so it is here. Now if you plot, if you join all these points, you will be getting a straight line, though I tried my best to make a straight line. I hope it is a straight line. So this is what the uniform negative acceleration, where the velocity of the object is uniform negative acceleration, where the velocity of the object is decreasing, velocity is decreasing, and it is decreasing uniformly. Do remember that here, if you have to find the acceleration, very simply you can find it. Suppose that you take any interval, say you have taken 1 to 2, so at 2 seconds what is the velocity? It is 20. So you will be doing 20 minus, at 1 second what was that? It is 30. So 20 minus 30 divided by time. V minus u upon t divided by time. What is time? It is 1. 2 minus 1, that is 1 second. So you will be getting the acceleration minus 10 meter per second square, like this. I hope it is clear to you. Thank you.